Okay, welcome back to this video. We're just going to cover what we did last week quickly, and then we'll move on to uh, getting the rest of the controller working. So if we move left and right, we'll jump. We've got the character moving. We've got the camera following with a small amount of interpolating or looping, so we can tweak those values. So that's what we've got set up. So what I want to do this week is, for those of you who want to know, like, how would I go about turning this into a controller that I could use, like, top-down or isometric. So to do that, I'm just going to select my floor. Okay, I just want to actually do something. In the code for our camera, I'm just going to turn the bolt camera on and turn the C# camera off. The problem is we set up these variables where we can get the camera offset, but I want that to be automated. I want that to grab the current camera position and feed that into the variable called camera offset. So let's just do that real quick. So in the camera follow here, we're going to right click and type in start to get the start function. And at the start, we're going to grab our camera offset variable, hold down Alt and drag it in to set it. And we're just going to get the camera's current position. So I'm just going to duplicate this node down here, and I'm going to plug that into there. So what happens here is, at the start of the game, it's going to find the camera's current position. So find camera's position and set camera offset to match. That's all it's doing here. So it's finding the camera position and it's setting the offset variable to match that. So all we have to do is, if you're an artist or if you have someone working in your game, all they need to do is physically move the camera to where they want it, and when they start the game, the camera is going to be at that position. They don't have to type in the values into a different place like we had to do over here. So if I zero out these values here, this camera offset, just to show you that it works, currently the camera is at 2.5 in the Y and -7 in the Z. So if I start the game, these values down here should update. There we go. 0, 2.5 -7, so we know it's working. And that just makes it a lot easier. So if I wanted to kind of pull the camera further out, and now the value is 2.5 and let's make this -12, those values will propagate through into the actual variables down here. So 2.5 -12. So that's what we want to do. We want to be able to allow the artist to change their stuff without having to worry about putting the values in two different places. Let's do the same thing for the C# camera. We're going to zero out these values as well, just to show that it works. I'm going to open up this in Visual Studio Code. Okay, and I'm going to type in start. And at the start, we want to type in camera offset is equal to transform dot position. Get the position of the camera where it currently is and feed it into the camera offset. It's that simple. You could also do this in the awake instead of the start. That is up to you where you would like to put that. As far as I understand, maybe I'm not looking at it properly, I haven't been able to find an awake function in Bolt. That's why I've always just used the start in Bolt. Okay, so if we do that, we'll get the exact same thing. The camera down here now gets the 2.5 and -7.5 variable value from the actual camera position. Okay, so that's it. That's how you kind of make part of the coding process a little bit better just by automating it. So we're going to turn the Bolt camera back on just to kind of continue with the rest of it. I just wanted to do that just to kind of show you how it. So I'm going to make this floor just like 3 meters by 3 meters by 3 meters. Just so I have a little area where I can run with my character. I'm going to grab my Bolt camera and I'm just going to rotate it at about 55 or 60 degrees in the X. And just move it up and reposition it so it's looking down on the character in the level. There we go. So if we start the game now, you'll see that the camera will remember where it is. So everything is working. The only problem is when I try to move up and down, we don't have input set up for that just yet. So we need to set it up. So currently we can only move left and right. We can't move up and down. So let's rectify that problem. So we're going to go to our player, Bolt code. And we need to go to where we have the update, where we're updating the actual Where is it? There it is. Go to our player input update, and we're just going to duplicate this node and just put it over here. We're going to use it now. And for the player input here, we need to create a new one called player input. Let's just call this player input Y. And that's also going to be a float. Now this is going to be for our what we call our vertical movement or our forward movement, depending if you're making a 2D game or a 3D game. So we're going to hold down Alt and bring that in to set the variable. We're going to set it to this one here. We're going to change it, so don't worry about that. We're not just replacing two variables with the same input, because right now it's horizontal, so we don't want that. We want to change the input that we're using over here. So as you probably have noticed, for those of you who know a little bit more about Unity, there is a new input system. We're using the old input system. I haven't found a really nice way to use the new input system in Bolt because there's no real support for it just yet. So once that is, we'll move over to the new input system inside of Bolt as well. So the second one needs to be vertical. There we go. And where I'm getting this from is just from the Unity's default action. So if I go to edit at the top here, I go to project settings, I go to input manager, you'll see that we have 18 presets here. We have horizontal, which is repeated twice, vertical is repeated twice, same as the fire 1 through 3, they're repeated twice. All of these things are repeated more than once, except for the mouse X, mouse Y, and the mouse wheel position. So I'm calling the vertical. So if I open up vertical, it's saying that if I press the up and down arrow keys on the keyboard, or I press the S and W keys, that's going to be controlling the character's up and down movement. And in the second vertical down here, it says if I use the left analog stick on my gamepad and I push away from me and towards me, that'll make the character move vertical. So that's what we want. We want to be able to control the character using a keyboard or an analog stick. And that goes for both of these inputs here. So once you set them up using these actions, they will work with both the keyboard and they'll also work with sorry about that, the gamepad. Okay, so now that we have this input, we need to actually just feed it into our controller. So the first part of this is going to be doing a 3D isometric top-down game. And then with the next video, we're going to go into how to repurpose this to I'll show you how to import sprites, I'll show you how to edit the sprites, set up animations. Using this current system with a little bit of tweaking, we'll be able to get the exact same result that we need. Okay, so we're going to go to our player input here. I'm just going to give myself some room to work with that. Okay, so I'm going to duplicate this player's input speed. Just bring it down at the bottom here underneath the gravity. So you never know, you might want to have a jumpy. You might want to be making something like Darksiders Genesis where you still need the gravity because there is jumping in this isometric game. We're just going to plug this into the Z. If you're wondering where I'm getting the Z, because we're doing a 3D game, X, as you can see in the arrow here, is the character's side-to-side movement, and Z is the forward and backwards movement. So we're plugging the next input into the Z so that the character will move up and down, and then when we press the horizontal input, we'll get the character going in the X position. Okay, so over here I'm going to change my player input to my player input Y, and that's pretty much it that you need to do here. I want to show you what happens when we do this so that I can show you how you're going to go about fixing the next bug that we have. So let's test this out to see how that works. There's quite a few things. Rotation's going to break, animations aren't going to play completely, but I just want to show you that if I move up, or not. Oh yes, sorry, before we continue, I completely forgot about this if statement here. So we need to duplicate this if statement because we're only checking for horizontal movement. So if we say player input Y is not equal to 0 or player input are not equal to 0, then please move the character. So that's where the problem was. I had to press diagonally or do some sort of side-to-side movement in order for the character to start moving. Okay, I'm just just going to make this little if statement. So all we did was add the secondary input into the if statement to make sure that if the character is moving based on either one of these inputs, then please move the character. Okay, so now we can try that again. There we go, character's moving. Left, right, forward, and backwards. Now notice when I press diagonally, the character moves a lot faster than he does if he's going left or right. Now the problem with something like that is because when you draw a graph and you have x, let's call it x position for sideways and y position for forward and backwards, they're both a value of 1, but when you draw a line to connect the two together on the graph, you are going to get a value around about 1.4, which is why the character is traveling faster. So we need to take these inputs and we need to make sure that they never go greater than 1 or minus 1. So we have a constant speed regardless of whether we're going diagonally, up, or right. So the way we're going to do that is we're going to feed it into the input here by grabbing the input here, breaking that, grabbing the player input y and breaking that. We're going to combine these two into a new vector 2. So we're going to drag out here and type in new vector 2 xy. This is going to be the x, and remember this is the y because we just called it y so that would make a little more sense. It's not really actually influencing the y position, it's just y on screen. That's the reason I set it up that way. Okay, so what do we need to do? We're getting these two inputs, and whatever value comes out of here needs to be a vector 2.normalized. The one with a d at the end. We need to get the normalized value from that, which means it's a value between 0 and 1 or 0 and minus 1. Okay, so once we have this, all we need to do is grab and separate these two out. So vector 2.x, get, do the same thing again. Vector 2.y, can we spell that correctly? Did not do a get, damn it. Let's try that again, vector 2.y. And now we have our x position, which is going to go into our side-to-side movement, and our y position, which is going to go into our forward and backwards movement. And that's pretty much how we're going to make sure that the character always moves at the same speed. So I'm just going to add a comment group around this. Call this normalize input values. There we go, normalize input values, which is what I wanted to do there, which is what I did. And now we can test this out to see if the character travels at the same speed, whether it's going up, down, left, right, or diagonally. More importantly, there we go. Notice how we get this kind of little bit of a drag. The reason when I release it, that's simply because we're using input.getAxis instead of input.getAxisRaw. So if you watch this if statement, when I run, it's firing. When I release it, it still fires for about a third of a second afterwards. That's what's causing that movement to go in there, and it's forcing feeding that value in there. So we want to just make sure we can get rid of that. So if you're making a top-down or a side scroller, the quickest and easiest way to fix this is to go over here and let's right click. I'm going to copy that name, right click, and replace input.getAxisRaw and do the same thing for this one, input.getAxisRaw, and let's see if that resolves the issue. Because you'll see now when we come here, getAxisRaw is either 0 or 1 or 0 and minus 1. There's no in between values. So it's gonna, so the moment I release the button, it stops firing. But we still need to do one more thing just as a fail-safe. I'm going to grab this rb.velocity. I'm going to duplicate it. Just going to put it up here, and I'm going to plug that into the false. I'm also going to duplicate this new vector 3 and plug that in there. So what happens is when I release those buttons, I want the x and the z position to be equal to 0. and then I'm just going to plug the gravity into y, just so that if he falls off a ledge and we zero out the force, it's going to kind of confuse the character and he's not going to be able to fall off the ledge. Let's try that out. So that's all we're doing there. It's just a backup just to make sure when we release the button, there we go, the character stops instantaneous. That way, if I'm running to a ledge, I don't get this. You can see it on the character on the right. He still takes a little bit of time to slow down. This one does not. Okay, so if we do that, we can also just go back here and switch these out if you want. If you want to be able to hold the analog stick lightly and have a walking versus a running. But for your standard kind of platformers, we can switch this over to get access raw and just get a straight up raw value. It's essentially going to be an integer. You're going to have whole numbers and no in between numbers. So there's not going to be interpolating or animating or blending of any kind as far as the speed of the character. It's just going to go from 0 to 1 in like a single frame. So that I think is what we're probably going to want to do in something like this. Just giving myself some more space here again, just to allow to move this down here. And I'm just going to put a comment group here. This one's going to be stop player movement instantly. When, yeah, stop player movement instantly. There we go. I think that'll make enough sense. It should. Okay, we're just going to pop this over here. Okay, so that's it for movement. He's now moving around. He's doing what he's supposed to do. He's no longer running faster when he's going diagonally. He's running at the same speed in both directions, all 8 cardinal directions. Now all we need to do is make sure he rotates in the correct direction. That's a simple one. We go to where we're doing the rotating and rotate the player. Over here, the player input, I'm just going to duplicate that node and change this to player input Y, and I'm going to plug that into the Z direction. Remember, that is the direction the character is moving. So if you're doing a 2D game, we're going to the Y, and you would probably only have a vector 2 anyway, so it would make sense in what direction to plug that in. So when the player, when I press up and down on the W and S keys, the character is going to rotate to go forward or backwards. So let's test that out again. Then all we have left to do is just kind of fix the animation so that it plays correctly. There we go. Character is now rotating in the direction he's supposed to be. Okay, so all that's left to do is make sure that our animator works correctly. So I'm going to go to my animator, which is up here. Move my animator up a little bit. I'm going to duplicate these 2 lines of code again. I'm going to change the second one to player input Y. You probably realize we're doing a lot of copy and paste. That's exactly what we're doing. All the functionality and logic were there already. All we have to do is just apply. So we're just going to add these 2. We're going to grab these 2 values, add them together, and plug them after the absolute. So don't do it before because you're going to get some weird results. So first, make the value absolute, then add the 2 values together and feed that into the animator. So you're going to get, again, these 2 values are going to give us something weird like that 1.4, but I'm not too bothered because remember we set up our blend tree to be between 0 and 1, so any value greater than that will still give me the same result that I'm looking for. There we go. Notice how the original one is only running left to right. This one is running in every direction, changing direction in relation to the inputs I'm giving it, playing the animation, whether it's left, right, up, down, also diagonally. There we go, that one's working. We're done with this. That is your basic movement. And you'll notice I actually didn't even do the jump. You'll see that the jump works as well. So if I'm running around, I press jump, the jump still works. So that's it. That is your completed. Now you're at a point where you can refine this, tweak it, change the speed values, change the gravity full multiplier, change the jump height, change a lot of things. You can tweak now. Now you're at a phase where all the core logic is in place. We're still going to tweak the jump a little bit for the guys doing the side scrollers, just so you can have a variable jump height. But overall, this is pretty much it for your top-down isometric or side-scroller movement. You have movement, you have jumping, you have your animations playing. So now everything on top of this is just adding extra to it. Whatever kind of mechanic you want to add on top of this, the system is in place. Okay, so I'm going to hide my bolt. I'm going to actually select my bolt camera. Just tweak these values. Make that, make that. No. Okay, I'm just going to copy this. I'm going to right click and copy this transform from the bolt camera. Turn the bolt camera off. Select the code camera, turn it on. Right click on the transform and say paste component values. And now both cameras are in exactly the same location. Now we can do the same thing. So I'm going to open up the script here. Waiting for the thing to do its magic and load up properly. And now we need to do the exact same thing. Exact same thing. So what did we do originally? We went in and added a new input. And we used that new input and fed it from the actual input itself. So I like to keep all of it together. So under this private float player input, I'm going to add another one. Private float. I'm going to call this one player input Y. So they're together in the grand scheme of things. So maybe I'll just move all the privates to the bottom here, just so that, just from like a layout point of view, I can see where all my serialized fields are versus where all my private variables are. There we go, player input. Just over here where we're storing the player input variable, I'm just going to copy this line and put it above this because it's going to be relevant to both lines of code. And I'm going to type here player input Y is equal to input dot get. I'm going to leave this one as dot get access just to show you the results, and you can go and change them afterwards if you want. There we go. We're getting our vertical, we're getting our horizontal, and we need to go and feed that directly into our actual movement. But remember what we did? We needed to get these values and normalize them and then feed them back into the movement. So just before we actually move the character, we're going to create a vector 2. I call it a throwaway variable. So we're going to be creating a localized variable or a throwaway variable, I like to call it. Let's call this input normal. Let's call it input normalize equals, and we're going to go create new vector 2, and we're going to input the two values. So the first one is for the x is player input comma player input y. So after that we're going to type in normalized, so we can normalize those values, and now we have the exact same thing we did in Bolt. We're taking these two inputs, we're normalizing it like we did in the code, like in Bolt, and then one step extra is where we're actually just creating a quick throwaway variable in code so that I don't have to go and create this and go normalize inside of the actual code down here. All I want to do is say input.normalize, copy, paste that where it says player input, and go .x, because remember this is a vector 2, that was a float, and all we need to do is go to where it says 0 at the end and type in input normalize.y. We're going to multiply that by player speed and then multiply that one more time by time dot fixed delta time, and that's it. That is how we get the input normalized up here. We're using that input inside of our rigid body dot velocity while still keeping our gravity here, rv dot velocity dot y. So if we save this and we go back, let it recompile, and you'll notice that it's going to work. Just okay, so notice what I did again. I made the same mistake. In the code, I forgot to change the if statement. So we have to go player input is not equal to 0, or player input y is not equal to 0. We just need to change that if statement. I'm making that mistake, and then I'm like, whoops, I forgot that. So we're saying whether you're pressing these buttons or these buttons, do something, or both. So And now it should work. The characters should travel at the same speed. Notice how he still takes a little while to slow down. Because remember, we haven't actually reset the velocity yet, but everything is working. They're both traveling at the same speed. So let's reset. Let's actually do the rotation, then we'll go and reset that. So for the transform.rotation, we know what we need to do. In the new vector 3, we have player input for x, so we need to go and put in player input for y for z. That way it will affect the rotation and the character will rotate in the direction it's supposed to. So if we go back here and test that one more time, the character will now look in the direction he's supposed to. His animation won't be playing yet, so don't worry about that. But there we go. Okay, so let's fix that animation issue. So under the if statement, so if the player input or player input y are being used, then do the following. We're going to do an else statement after that. So else, if there isn't, all we're going to do is say rb.velocity is equal to, we're going to go new vector 3. We're going to go there, and we're going to go 0 for the x because that's what we want. We're going to go rb.velocity.y for the gravity, and then 0 again for the z. We're just going to zero out that movement the moment we release the buttons. There we go, let's test this out. Okay, we still have a little bit of a slowdown, so we could do something else. We could, instead of doing this here, we could go and say no, we can leave it like that. We're just going to change at the top here, get access to get access raw. We're just replacing these two values to make it exactly like the bolt, so we get sudden stop. But there's a lot of other ways we can tweak this. We'll show you. We can go further on once we have all the systems in place. There we go. They both stop exactly the same amount of time. There we go. Now all that is left again is, remember, we look at our code here. We're in the camera right now. How about we go into the over here for the animation? First, we're getting the player input absolute value, and we're getting that absolute value, and then we're combining the two values together and adding it to the animator. So we need to do the same thing in our code. So let's go to our code. What the heck was that? Save. Okay, so over here where we're doing the animator, there, we're getting mathf.absolute. We're just going to do the, after that we're going to go plus, not inside the brackets, preferably outside between the last two brackets, plus mathf.absolute, round brackets, we're going to go player input y, and that's it. So remember, we're getting the absolute value first, and then we're adding those absolute values together and feeding it directly into the animator. So if we do that, we're going to get the result that we are looking for. There we go, up, down, left, right, diagonally, works. There we go. So now we have two fully functioning systems, one using Bolt, one using code. They can both jump. They both have in-air control. We could also adjust that if that's what you guys don't want. There we go. And that is working. So that's pretty much it for this video. I just wanted to show you how to convert your 2D game controllers. Okay, so don't do what I just did. I did not duplicate those scripts. So now I've overwritten my side-scrolling script, but that's okay. I can go in and add a little boolean later on to kind of say whether this is a top-down or a side-scroller. But that's it for this video. I hope this has been helpful. Again, if you have any requests or anything you'd like to actually see, I would like to see what I could work on next. But the next stage here would just to kind of focus more on the pixel art guys and the 2D guys and what they need to do or what they should do. And then after that, we're going to work into like systems. What can I use this for? I've just made a character that moves around. what can I do with this controller? What systems can I build, or game mechanics to build on top of this, that sort of thing. So thank you so much for watching. Till next time, be safe.